All right, Algebra 2. Hey, welcome back, guys. We are jumping into section 2 now today of chapter 5. All right, so we're talking about properties of quadratic functions. And we will be doing a little bit more graphing, but you'll be doing kind of a lot more calculations. All right, so the last section dealt with the translations, movements, left and right, up and down, all that stuff. This still has a graphing part to it, but there's a lot more in the world of calculation. So let's jump right into it. Okay, we got 3 charts. You're going to need to know the charts. All right, this isn't one of those recommend it. This is you got to know these charts. Okay, so I gave you the page numbers of where these charts can be found. Copy these charts into your notes. And again, listen, if you're not taking the time to do this, you're only hurting yourself. All right, so think about it for a second. It's worth the time now so that you can make sure you are saved and good to go later. All right, so copy those charts. Let's move on. So we're talking about the axis of symmetry. You're going to see that terminology, and you're going to remember this is the vertex form of a quadratic equation. Okay, so the axis of symmetry is basically a perfect vertical line that goes directly in the middle of the parabola that is made by a quadratic equation. All right, there's a lot of words there that basically mean you make that parabola, you got a smiley face or you got a frown, and you could cut that parabola perfectly in half, right? Axis of symmetry, the word symmetry is in it. If you were to cut it in half, basically fold it like a piece of paper, that line is the axis of symmetry that will go right in the middle. And if you have a vertex form, like you're looking at right there, which is a parentheses x minus h, that one, then all you have to focus on is the h. All right, x, which represents the axis of symmetry. Look at the h, though. I know it's a little confusing. You're going to see x equals, and yes, there's an x in the equation, but what you care about is the h. Now, negative h is what you're focused on. If you notice that h, it says minus h, then what's going to be coming out is right. Let's see if I wrote that. All right, I didn't put that right down there. Oh, yeah, no, I did. Sorry. As you can tell, I'm fully focused on my own notes here, right? So if you have a minus h, which it says right there, then you're going to get a positive axis of symmetry because negative, negative makes a positive. But if you have a plus h in that equation, then you will be getting a negative axis of symmetry because a positive and a negative will make a negative. All right, you will see a problem like this. So keep working with the video, pay attention. All right, standard form, however, that's the ax squared plus bx plus c. You're going to see a lot more of that in this section, okay? The axis of symmetry for that, so let's get right there. That is going to be calculated by doing a negative b divided by 2 times a. And if you look at the equation there, a, b, and c will be actual numbers. The x squared and the x will just be the variables, okay? So when you see x equals, that's you calculating the axis of symmetry. Now, once you have that axis of symmetry, so now we're looking at one of the lower notes here. Once you have that axis of symmetry, you're going to plug it back in to the standard equation, solve for y, and now you're going to have the x and y values that are the coordinates for your vertex, okay? Which the vertex right there is going to be the line, sorry, is the dot where the axis of symmetry crosses, okay? And this last note here, you actually already know. We talked about this in our notes yesterday, okay? So let's take a look at some example problems. Let's jump into it. All right, so what we're looking at here is a vertex form of the quadratic equation. And if we go back up to a vertex form right there, how do we get the axis of symmetry? We focus on h, and we need to make sure, is it a minus h or is it a plus h? It's a minus h. So what that means is this guy right here is what we're focusing on. If we're in the vertex form, life is easy. All right, there's no calculations you have to do. You just have to find h. If it says minus h, then you're simply writing x equals now a positive 3. All right? Because if we go back up to the note, I know I'm harping on this a lot, but I need to make sure you understand what the signs will do to the axis of symmetry. Look in that note. Read that whole thing. In the equation, this means if it is a minus h, you will get a positive axis of symmetry. So when we go back to the problem, it does say that. It says minus 3. That's a minus h, so the axis of symmetry is just 3. Boom. One done. Let's move on to the next one, which will take a lot more time. All right, standard form. Here we go for standard form. You see a negative 2. This is our A value. This is our B value. And you'll notice there is no C. So what does that tell you about C? That would tell you that C equals 0. If there's no C value in there, then C is 0. Okay? So let's use the equation negative B over 2A. All right, so we have B. B in this case is already a negative 4. All right, so if it's a negative 4 and in the equation it says negative B, what does that do? That means now we have a positive 4 divided by 2 multiplied by A. What is A? A is negative 2. Negative 2 times 2, we're looking at negative 4, which equals negative 1. So what did we just calculate here? We just calculated the x value for the axis of symmetry. Okay, so now we have the axis of symmetry. This is part of what we were asked to do. If you look at the directions, all right, technically the first thing was determine if the graph opens up or opens down. What do I focus on there? All right, opens up, opens down. Focus on this value right here. That value is a negative. So we will say this is going to open down. All right, if A is a negative, opens down. A is a positive, opens up. All right, so we have the first part done, the second part done. Now we need to find the vertex. How do we do that? We do that by taking that negative 1 and plugging it back in to the x values of the original equation. All right, so we're going to need a little bit of space here to write this out. So we got a negative 2 parentheses negative 1 squared minus 4 parentheses negative 1. And let's calculate that out. So negative 1 squared is 1 times a negative 2 is negative 2, negative 4, negative 1. That makes a positive 4. So we're looking at 2. All right, and that would be our y value. So 2 equals y. And remember, the vertex is x and y put together. So the coordinate would be negative 1, comma 2. All right, that would be the vertex. And then what's the final piece? All right, let's find the y-intercept, which, let's see, let's graph it. Okay, when we graph it, the y-intercept will show it very clearly. So now let's use these calculators. You spent the time and money to get the calculator, so let's use the calculator. Go to y equals, plug in a negative. Don't forget it's a negative 2, don't say minus 2. So negative 2x squared minus 4x. You don't have to put plus 0. It's not going to change it. Hit graph. All right, there we go. Okay, it is opening down. That is true. And it looks like the y-intercept is 0. That is where it crosses the y-axis. Okay, so right here, y-intercept, that is 0. And let's go ahead and graph it. So we are, looks like we got a dot right here. We got a dot right here. And it looks like we got a dot right here. All right, there we go. That is our parabola opening down. And I know that was a decent amount of work. So you got to make sure you're paying close attention to all the parts that we just had to do. Because in one problem, they ask us to do all that. And lucky for us, the next one, same style. All right, we got to do all that. So let's get through this one a little bit faster now that we've done one. Okay, first look at A. What is A? Doesn't look like there's anything there, but there is a coefficient. It's 1. Okay, so let's write out our values. A equals 1, B equals 3, C equals -1. So now we know what A, B, and C are. A is a positive, so this is going to open up. All right, first part, done, taken care of. All right, next part, what are they looking for? Axis of symmetry. How do we calculate that? By using -b over 2a. What is b? B is 3. So a -3 divided by 2 times 1, which in this case is still 2. So that means our x value right there is a -3 over 2. And if you're seeing the writing on the wall here, fractions are not so fun. So we have to now take this value and plug it in here and here. All right, so again, use the calculator here. It's okay, all right? We are out of Algebra 1. We're in Algebra 2, so you can use your graphing calculators. All right, they have all those abilities to do the calculations for you. So I'm going to write it out, but then plug that in directly to your calculator, and let's get that value. So here's what we would do. Parentheses, -3 over 2. We're squaring that, plus 3, parentheses, another -3 over 2, minus 1. All right, work that out on the calculator, plug it in. I've already done that, so you're going to get a value of -13 over 4. Yeah, that is our y value. So now that we have x and y, we now have the vertex. All right, so we have a -3 over 2, comma, -13 over 4. All right, and the vertex, remember, that is the dot where the perfect axis of symmetry line will cross. All right, so if we go back to A right here, we should have basically at -1, comma 2. So really we would go 1, 2, and we know that that dot should be like right about there. Okay, so let's go back to this one where, again, it's not a pleasant perfect number. It's a fraction. So we're going to go with approximate, closest as we can get values. So we got 1. Let's go 1, 2, 3. We're a -3 over 2. That's just a little bigger than -1. And then -13 over 4. Let's see, that's going to be just a little bit bigger than 4. So we have 1, 2, 3, 4, a little bit bigger than that. Okay, so we're going to go left. By the way, we could plug this into the calculator. And let's go ahead and take the time to do that. The original equation. All right, let's do that. You got x squared plus 3x minus 1. Okay, plug that into the y equals, hit graph. That way you're now going to have a good visual of roughly where this will be in terms of in the coordinate plane. So that dot, because it doesn't show perfectly in the graph, but we know that that dot is going to be a little bigger than -1 to the left and a little bigger than -4 down. And that means we are right about there. Okay, now where does this cross the y-axis? And if you wanted to do that, you could now use the graph. When you're on the graph function, hit the left arrow, and you'll notice that there is a little cursor that comes up. And if you get that cursor right where the x crosses, it is going to be at about, oh boy, yeah, that's a real difficult one. It's at -3 over 2. I think that's perfect. Yeah. Nope, it's at -1. Yep, that's a lot more. Yep, a lot more accurate there. So -1 is where we're crossing the y-axis. So right there is where we're crossing the y-axis. And now let's go ahead and make the rest of our graph. So right there. Right there. Okay, so there's our graph. Now let's double check that we've done everything asked. We have opens up or down, axis of symmetry, vertex, y-intercept, and graphing it. We did all parts. So you can see in one of these problems, there's a lot of steps. There's a lot of things you got to pay close attention to. When it comes time for grading of homework, you got to make sure you have all these different parts to get the full credit for the one problem. All right. And we got one more to do, and I'm going to teach you how to use the calculator for sure on this one. Okay, so you have a minimum or maximum value. How do we calculate minimum or maximum? First, we have to figure out, what is this? Is it minimum or is it maximum? And the way we do that is by determining if it opens up or if it opens down. And what do you look for? You look right here, and you see that there technically is a coefficient of 1 right there. And it's a positive 1. So that means that this is open up. And if they open up, you actually have a minimum. If they open down, you actually have a maximum. And how do we do that? Because if it's a perfect smiley face, you're looking at the bottom of the graph, which is the minimum point. But if it's a frown, you're looking right there at the top, which is the maximum point. All right, so let's go ahead and use the calculator. Go back to y equals, clear it out, and plug in exactly what you're looking at there. X squared minus 6x plus 3, hit graph. All right, take a look at what we got. Okay, so it's not going to be easy just by looking at it to calculate what that minimum value is. All right, this is a rough estimate of what your graph looks like if you did it correctly here. Okay, we're like right over there, right? So that's like a rough graph of what it really looks like. But if we want the specific minimum value, here's what you do. Now, looking at the graph, you're going to hit second and then calculate. It's directly next to the graph button. It's right above trace. That's what it is. Okay, and now if you look down, number 3 should be minimum. All right, so go down to number 3 and then hit enter. Now, if you're looking at your calculator, it should say left bound. Now, what you need to do is hit the right arrow. If you're looking at my calculator, at least, I need to get that blinking X that's on the screen as close to the minimum value, like right there at the bottom of the graph as possible, but slightly to the left. That's what left bound means. All right, so I'm going to get just to the left of it and then hit enter. Then it should say right bound. So now you need to get just to the right of that lowest point in the graph. And when I say lowest point, I'm talking about the lowest point right there. Okay, so then hit enter for the right bound, and now it's going to say guess. So that means I'm going to get actually right on that lowest point, as close to that exact point as I can get, and then hit enter again. And what this is now doing is it's calculating the exact minimum value for that graph. And if we did it properly, that exact minimum value that comes up on my side is, let's see, X is 3 and Y is -6. That's what comes up perfectly on my side. So that would be 1, 2, 3. Now, clearly, I did not go down enough in this little estimated graph here, but this technically down here would be at -6. All right. Now that we have that value, we just got to calculate domain and range. You remember, domain, that is your x's, and range, that is your y's. Well, if you look at this, technically this is going to go infinity in both directions. Then you will have an x value that never stops. So that means the domain is all numbers. because you will cover every x value in both directions. It's the range that is actually going to have a specific value here. Now, what is that value? It's the 6 right there, because we only went down to -6, and we're going to go up infinity from there. So that's going to be y is greater than or equal to -6. That is going to be the range value. All right. We don't go any lower than -6, but we do touch -6. That's why it says or equal to. But we go vertical up from there, meaning y is getting bigger from that one point. Okay, that's it. That covers the whole section. Please write down your questions. All right, make sure, write down your questions. Come to class. If you don't get a part of the video or the notes, ask me the next day during class. All right, thanks, guys. See you in the next one.